You're live, sir. You can start.
Okay, hi everyone. I think there are some students joined here for the live session. So maybe you can start asking your questions in the chat. There is a question here which says, how do information sets change when we have imperfect information? So let me answer this question. I'll share my screen and I'll show you. There seems to be a lag between my video, what I am doing and what is visible on YouTube. This is how it usually is. Somebody from NPTEL, can you answer this? Okay, I will go about answering the question on information sets. Okay. So an information set is a collection of nodes, or vertices in the game tree. In the game tree that belong to one player. Okay? They belong to just one player, and the player is unable to distinguish between. So each node in the game tree corresponds to a sequence of actions that have been taken before. And now, when these nodes are all belong to one player, it means that when the game reaches any of those nodes, it is the turn of that player to act. So, for example, if these three nodes are all belonging to, let's say, player two, then if they belong to player two, it means that they are in player two's player set. We call this player set. So they are a part of player two's player set. There could be other nodes also in player 2, player set, but these are some of them. Okay. Now, when we see these nodes in player 2's player set, we can, if they are, if the player, there may be two situations. So if the player 2 may be able to distinguish that he is at this node or this node or this node, or it may be that player 2 is unable to distinguish which node he is exactly. So you can have three possible nodes, you can have these three possible nodes in which player 2 is not able to distinguish where exactly he is. All he can say is that he is at one of them. So all he can say is that he is at one of these three. In that case, we put all of them into one information. So then this orange thing is what is called an information. So if the information, so if you have, if the information, if two nodes are in the same information set, then it means that a player is unable to distinguish between. In this case, I have drawn three nodes in one information set. There can be three nodes, there can be four nodes, two nodes, whatever, any number of nodes in an information set. Now, in the extreme case, it can also happen that there is only one node in the information set. This is an extreme sort of degenerate case in which there is exactly one node. The information set comprises of only one. In that case, then the player actually has perfect information about it. So he knows exactly that he is in fact at that node. So an information set tells you the level of ignorance of that the player. So if there is if you have more nodes in the information set, it means the player is unable to distinguish between any one of them. So that means that his level of ignorance is more. On the other hand, if there is only one node in an information set, then the player knows that he is exactly at that information, at that node. Right? So then the information directly tells the player which node he is in fact at. So now, based on this, what we can talk of the two types of games. So there are games of perfect information, and there are games of imperfect information. So when you have a game of perfect information, it means that what that means is that every player, in this case, every player, every information set. So every information set of every player, every information set has exactly one node in it. Which means that every player, regardless of where the game is, knows exactly what the previous sequence of actions has been. So he knows exactly which node he is at, and he knows exactly what has happened in the past. Okay, so this is what a game of perfect is. So if it is not a game of perfect information, then it is a game of imperfect information. So imperfect information simply means that some player, there is one at least one player, there is some player who has an information set with more than one. So there is at least one player who has an information set with more than one node. This is the game. This is what it means for the game to be of imperfect. So now your question was, how do information sets change when we have imperfect information? And the answer is basically exactly this, that when you have perfect information, the information sets are all single, in that they all comprise of only one vertex. Each information set has exactly one vertex. But when you have imperfect information, there is at least one information set which will have more than one word. So let's say two words. Okay, let's say these two words that are in the same. Something like this is a case of imperfect. So does that answer the question? I don't know if students can respond back to me. If you have further question, you can ask. I will come back to you. So let me now go to the next question. For simultaneous move games, two players have to play simultaneously, or even though the decisions are made sequentially, because of the information set, we can call it a simultaneous. Yes. This is a good question. I have made this point in my lectures also. So simultaneous move game. Okay, does not actually mean that players are in fact playing exactly at the same time. Simultaneous move game does not mean players are play at the exact same time. Players can play sequentially also. Okay, so players can play sequentially. In fact, the exact order of play is immaterial in simultaneous move. Players can play sequentially, but player one can play first, then player two, or player two plays first, then player one. Any order is okay. What makes a game simultaneous is not the order of play, but rather what do players know when they play. Okay? So the game is a simultaneous move game if the players are not aware or do not have the information of the actions of the other player while choosing their own. Okay? So if there are two players, player one, player two, then you can have that player one plays at 2 p.m. and player two plays at 2:30 p.m. Means he picks an action, let's say action x1 at 2 p.m. and player 2 picks an action x2 at 2:30 p.m. Okay, but what is important is this will still be a simultaneous move game if player 2 did not know, at 2:30 p.m. what is it that player 1 had to. So, what that player 1 had chosen is not available to player 2. So player 2 is not aware of this. If player 2 is not aware of this, then it is as good as that player 2 has played either at the same time as player 1 or even before player 1. Right? So, so, so it is so this situation becomes equivalent to player 1 and player 2 both playing at the same time. So it can, so now in this case what I have assumed is that player 2 because player 2 is choosing his action later after player 1 obviously does not know of player 2's action. Okay, so there is no way for player 1 to actually know what player 2 has done because player 2 is going to act later. So player 1 does not know of player 2. Player 1 does not know of player 2's action. But player 2 could have known, but that is also not being allowed because of this. So there is no information that is being transferred from player 1 to player. And because of that, then it is equivalent to both players playing exactly at the same time, as if they are playing at the exact same instant. So that is why we use the word simultaneous. Simultaneous is not to be taken in the literal sense as simultaneous according to a clock, but rather it is based on the information that is being shared. Information-wise, this is accurate. This is this is the answer to your question. Whether a simultaneous move game requires players to play simultaneously, or can they also play sequentially? Any other questions that anyone has? I'll be happy to answer. Are these the only questions? Are there any more questions? So I don't know what NPTEL team, should we wait for Ankur, for the question.
Sir, this is up to you. You decide. If you want to wait, you can wait or you can stop the session.
Yes, there seems to be nobody else, so I think we can stop the session. Students, if you still have questions and are for some reason unable to join in this live session, you can always write to me. I'll be happy to answer. So shall we disconnect?
Okay, sir, we'll disconnect now.